What's going on, everybody? Back for another video. This is differential equations, and we have Cauchy-Euler equations. All right, so let's get started. It says a linear differential equation of the form a sub n x to the n times the nth derivative of y with respect to x plus a sub n minus 1 x to the n minus 1 times the n minus 1 derivative of y with respect to x, all the way down to a1x dy dx plus a0 y equals g of x, where the coefficients a sub n to a0 are constants, is known as a Cauchy-Euler equation. Notice the degree k equals n minus 1 to 1, and to 0 of the monomial coefficient x to the k, matches the order of differentiation. So basically what they're saying here is the exponent here matches the nth order derivative. Okay, so just writing it again, it's like I'm showing you here, these are the same. Okay. All right, note the lead coefficient a sub n times x to the n of any Cauchy-Euler equation is 0 at x equals 0. We will focus on finding general solutions defined on the interval 0 to infinity, and the interval negative infinity to 0 can also be used. Okay. All right, so method of solution. We try a solution of the form y equals x to the m. That's what you need to remember right there, where m is to be determined. So basically, what we're going to do is we're going to solve for m. A sub k to the x times the kth derivative of y is equal to this: ak x to the k m times m minus 1 times m minus 2 to m minus k plus 1 times x to the m minus k, which is equal to this right here. Notice the x to the k is gone, and it'll make more sense once we start working the examples. Says, for example, when we substitute y equal x to the m, the second order into the second order dE, so we've got the differential equation here, becomes this: a m minus 1 x to the m plus b m x to the m plus c x to the m. Okay, and then we're going to factor out an x to the m. You see that, factoring it out right here, and we're left with this equals 0. Thus, y equal x to the m is a solution of the differential equation whenever m is a solution of the auxiliary equation. We have am minus 1 plus bm plus c equals 0, or am squared plus b minus a m plus c equals 0. And it just basically distributing here and combining like terms. That's all we're doing there. But like I said, it'll make more sense when we start working the examples. Just hang in there with me, and make sure you hang in to the end of the video, because we're going to work a pretty interesting problem at the end. All right, so case 1. And this should seem familiar. Remember back when we solved homogeneous equations that did not have that did not have these variables. The coefficients were constants. Remember, you would set up your auxiliary equation and solve for m. So it says let m1 and m2 denote the real roots of, and this star here, that's referring to this. Okay, whenever you see the star, it's going to refer back to this equation here. We're solving this equation here for m. So let m1 and m2 denote the real results of star such that m1 does not equal m2 Then y1 equals x to the m and y2 equals x to the m sub 2 form a fundamental set of solutions. The general form is y equals c1 x to the m 1 plus c2 x to the m2. All right, so let's go ahead and solve these examples here. All right, so remember, it says, if I can find it again, okay, for example, we substitute this solution into the equation. So we're going to assume y is equal to x to the m. All right, so we've got y equals x to the m. So y prime is m x to the m minus 1, and y double prime is equal to m times m minus 1 times x to the m minus 2. All right, we have to plug x to the m in for y, and then we need y prime, which is this, and then we need y double prime, which is this. So now what we're going to do is plug all of this into our differential equation. Now for this example and this example only, I'm going to show all the algebra steps, okay, all the steps, and then as we go I'll leave some of those out because I'm just not going to write it every time. All right, so we have x squared, and then we plug the second derivative in, so that's m times m minus 1 times x to the m minus 2 minus 2x times the first derivative, which is mx to the m minus 1 minus 4 times y, and y is x to the m, and that equals 0. All right, so I've got x squared, m squared minus m. I'm just distributing the m here. And now this one right here, I'm going to write as x to the m times x to the negative 2. That's how I wrote this. Okay, so if we multiply this back out, this is x to the m plus negative 2, which is, this would be x to the m plus negative 2, which is m minus 2. Okay, so I just split it up. And then that's minus 2xm x to the m times x to the negative 1 minus 4x to the m equals 0. All right. And so notice here how I have a common factor of x to the m. So what I'm going to do is I'm going to factor out that x to the m. So that's, whoops, let's switch colors back. So I've got x to the m times. Now notice this term and this term. If I multiply these two together, that's x to the 2 plus negative 2, which is x to the 0, which is just 1. Okay, you see that? And same thing here. When I do x to the first times x to the negative 1, that's x to the 1 plus negative 1, which is x to the 0, which equals 1. Okay, so these terms here, those go to 1. So they're basically gone. All right, so I've got m squared minus m minus 2m minus 4 equals 0. All right. And so this is going to give me x to the m times m squared minus 3m minus 4 equals 0. And then what we're going to do is take this and set it equal to 0. Because, I mean, this term will never be 0. So we take this, set equal to 0, m squared minus 3m minus 4 equals 0. And then I factor m minus 4 times m plus 1 equals 0. So m equals 4, or m equals negative 1. And so what do we get as our solution? Well, we get y is equal to, and notice what it says here, y is equal to c1 x to the m sub 1 plus c2 x to the m sub 2. And so I've got c1 x to the negative 1 plus c2 x to the 4th. Now, you might be thinking, well, why is that not m1 and this m2? It doesn't matter. You can write c1x to the fourth plus c2x to the negative 1. That's fine. It doesn't matter. A lot of times what I do, now I may not do it every time, but the majority of the time I would say probably what I do is I just write from smallest to largest exponent. Okay, it's not wrong if you don't, but that's just what we do, or what I do. All right, so that was case 1, where we had distinct real roots. We had m1 roots m1 and m2. They were not equal to each other. All right, now let's look at this case 2, repeated real roots. If the roots of star, that refers back to that equation up here, okay, that is this equation right here where I put the star, this one right here. So if the roots of that equation are repeated, so m sub 1 equals m sub 2, the general solution is c1x m to the 1 plus c sub 2 x m to the m sub 1 times natural log x. So if you remember when we solved the homogeneous equations where we had constant coefficients in front of the derivatives, remember it was e to the mx, and if you had a repeating it was x e to the mx. Okay, well, this is for these types of equations, we're multiplying the repeated one by natural log x. All right, so let's go ahead and get this. So we're going to assume solution y equals x to the m, and I need all the way to the second derivative. So y prime is mx to the m minus 1, y double prime equals m times m minus 1 times x to the m minus 2. And we're going to plug everything in. So I get 4x squared times m minus 1 times x to the m minus 2 plus 8x times m times x to the m minus 1 plus y, which is x to the m, and that equals 0. All right, so this is where I'm not going to show this where I separate the x to the m and the x to the negative 1. Just know we're factoring out of x to the m, and this one and this one are going to cancel. This one and this one are going to cancel. And we're factoring out of x to the m. Okay, that's why I showed all the work in the first one, so you wouldn't be sitting there wondering, well, what happened there? Where did all that stuff go? All right, so we're factoring out of x to the m, and remember the x squared and the x negative 2 to the negative 2 is going to go out, so that's going to leave me with 4m times m minus 1 plus 8m, right? See, the x to the m comes out, and times x to the negative 1, that goes to 1, plus 1 equals 0. And so I'm going to get x to the m times 4m squared minus 4m plus 8m plus 1 equals 0. And so that's x to the m times 4m squared plus 4m plus 1 equals 0. And so we got 4m squared plus 4m plus 1 equals 0, and this is going to factor 2m plus 1 squared equals 0, so m is equal to negative 1/2. And so I got m equals negative 1/2, but this is multiplicity 2, so I've got 2 solutions. So let's just write it out. m1 is negative 1/2 and m2 is negative 1/2. Okay, and so now I've got y equals c1 x to the negative 1/2 plus c2 x to the negative 1/2 times what? Times natural log x. Okay. There you have. See, it's really not that bad. It's not that bad. All right. And now case 3. Conjugate complex roots. So if the roots of star, that equation back at the beginning, are the conjugate pair m1 equals alpha plus I beta, m2 equals alpha minus I beta, where alpha and beta are positive and they're real, the general solution is y equals x raised to the alpha times c1 cosine beta natural log x plus c2 sine beta of natural log beta times natural log x. All right, so let's take a look at this. So you can see here, this problem that we're working here, this one is this one's going to be a little more involved, not so much as solving the differential equation, but this is an initial value problem. We have the conditions here. Okay, so we're going to have to do a little extra. We're going to actually be able to solve for C1 and C2 now. All right, so I'm going to assume y is equal to x to the m, y prime is x to the m minus 1, y double prime is x to the m minus 2. Nah, what am I doing? You dummy. I'm sorry, I got something else on my mind, and I forgot to I didn't bring the exponents down, did I? All right, so here we go. So I've got 4x squared times m minus 1 times x to the m minus 2 plus 17x to the m equals 0. Okay, so there's no y prime in there, so we don't have to plug that one in, but we did have to find it because we need the second derivative also. All right, so now we have, so let's factor out a x to the m. Okay, and then remember the x squared times x to the negative 2, that goes to 1. So I'm left with 4m squared minus 4m plus 17 equals 0. All right, so now I've got 4m squared minus 4m plus 17 equals 0. And we have to solve for m. This is not going to factor, so we have the quadratic formula. So m is equal to negative b, so that would be a plus 4. Negative and negative 4 is plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And when we do that, we're going to get m is equal to 1/2 plus or minus 2i. Okay, I'm not going to go through simplifying, doing the arithmetic. So when we get this, you can see here alpha is equal to 1/2 and beta is equal to 2. So we're going to get y is equal x to the alpha, right? So that's x to the 1/2. See here, x to the alpha. And then c1 cosine beta natural log x plus c2 sine beta natural log x. And so that's going to be times c1 cosine 2 natural log x plus c2 sine of 2 natural log x. All right, so now excuse me, so now what do we have to do now? Well, we've got our conditions. y of 1 is equal to negative 1, y prime of 1 is equal to negative 1/2. So what I need to do is I need to take the derivative of this thing. Whoops, and I need to put a bracket right there. All right, so the derivative y prime. All right, so this is product rule. This is our first function, and this would be our second function. So I'm going to do the derivative of the first function times the second function. All right, and then it's going to be, I'm going to have to come down here, and then it's plus the first function, which is x to the 1/2 times the derivative of this one. Okay, so here we go. So let's just kind of walk through it kind of slow. So this is going to be negative c1, because the derivative of cosine is negative sine, right? So that's negative c1, and it's going to be negative sine 2 natural log x, right, times the derivative of what you're taking the cosine of. Well, the derivative of natural log is 1 over x, so that's going to be 2 over x right here. All right, plus, I need another parenthesis there, plus, and then derivative of sine is cosine, so that's going to be c2, derivative of sine is cosine 2 natural log x times the derivative of what you're taking the sine of. Well, that's going to be 2 over x, and we'll close the bracket there. Okay, so as far as that first derivative goes, I mean, could you simplify it some? Maybe, I don't know, but we don't really need to, because all we're doing is plugging 1 in for x. So I'm not even going to worry about simplifying it. All right, so notice I'm going to go ahead and write the conditions down. I'm going to write them down right here. Y of 1 is equal to negative 1, and y prime of 1 is equal to negative 1/2. Okay, I just copied these down again. All right, so now we've got y of 1 is equal to, that's going to be 1 to the 1/2 times c1. Okay, now let's just kind of let's just go through this real quick. So I'm going to plug 1 in for x. Natural log of 1 is what? 0. So let's just go ahead and write cosine 0, right? I'm plugging 1 in for x. Natural log of 1 is 0. Cosine of 0 is, well, we know cosine of 0 is 1, but we won't write that just yet. Plus, all right, c2 sine, and I'm plugging 1 in here. Natural log of 1 is 0. Sine of 0 is what? 0. So that term just goes. Okay, so we don't have this anymore. And this is equal to negative 1, which this means that this is 1, this is 1. So this tells me C1 is equal to negative 1. All right. All right. Now let's do y prime of 1. So I'm going to have 1/2 times 1 to the negative 1/2, right? Plugging in 1 for x. I'm using this one. And then once again, this is going to be times. All right. So I plug 1 in for natural log. Natural log of 1 is 0. So that's cosine of 0. So that's C1 times cosine of 0. Cosine of 0 is 1. So 1 times C1 is just C1. Okay. All right. Now plug it into this one. So if I plug 1 in for x, that's the sine of 0, right? Sine of 0 is 0. That term's gone. so we don't need to worry about writing it down. So I'm just going to put that as times C1. Okay. All right. Now, I've got plus, and now we have x to the 1/2, so that's 1 to the 1/2. We're plugging it into here. So look at this. When I plug 1 in for x, I get sine of 0. Okay, and yes, I'm plugging a 1 in here too, but this term right here is 0, so this whole thing is 0. Okay, and then we plug 1 into here, so that's going to be plus C2 times 2 over 1, right? Plug the 1 in for this x, and natural log of 1 is 0, cosine of 0 is 1, so times 1, and this is equal to negative 1/2. And so this gives me, this is 1/2 times 1 to the negative 1/2. This is just 1. And what did we find out about C1? C1 is negative 1. So this is going to be negative 1/2 plus, well, wait a minute, what did I do? Oh, that shouldn't be a plus there. That should be a times. All right, and then this is going to be what? Plus 2C2 is equal to negative 1/2. And so basically, this is going to be 2C2 equals 0, which means C2 is equal to 0. And so we get y is equal to negative x to the 1/2 let's see, where are we plugging this back into? Right here. Okay, I'm replacing this with negative 1. Let's see, C1 is negative 1. So I'm plugging negative 1 in for C1. Okay, so that's going to give me negative x to the 1/2. And then it would be cosine 2 natural log x. C2 is 0, so that's gone. So that would be cosine 2 natural log x. And there's your answer. All right. So it's not too bad. It just got a little nasty there when we had to do that derivative and stuff. All right, let's look at this one. All right, so we got y equals x to the m. Y prime is m x to the m minus 1. Y double prime is m minus 1 x to the m minus 2. And y triple prime is m minus 1 m minus 2 x to the m minus 3. That's an m there. I had to squeeze it in. I was running out of room there. So now let's plug everything in. So I get x cubed m minus 1 m minus 2 x to the m minus 3 plus 5 x squared m times m minus 1 times x to the m minus 2 plus 7x times m x to the m minus 1 plus 8x to the m, and that equals 0. So we just plugged each of those in for those derivatives up there. And once again, I mean, look at this. So remember the x cubed and x to the negative 3, that goes to 1. I'm factoring out x to the m. So I get x to the m times m minus 3m plus 2. I foiled those two. Okay. And then plus 5m squared minus 5m plus 7m, yep, plus 8 equals 0. Alright, so now I've got to do x to the m times, and that's going to be m, whoop, that should be an m squared there. So that's going to be m cubed minus 3m squared plus 2m plus 5m squared minus 5m plus 7m plus 8 equals 0. Alright, so then what we're going to do, combine like terms here. This is going to be x to the m times, and that's going to give me m cubed plus 2m squared plus 4m plus 8 equals 0. Now, I have m cubed plus 2m squared plus 4m plus 8 equals 0. All right, so this is what we have here. Now, all right, so look at this. So on this one, we solved one like this in an earlier video where we had to get the factors of p, the factors of q, and then you do the p over q and you use synthetic division to see if it's a 0. You got to kind of do trial and error there. Okay, so could you do that here? Yeah, probably so. Well, yeah, you could, but look at this. Okay, do you remember factor by grouping? So I split it down the middle, so that's m squared times m plus 2 plus 4 times m plus 2 equals 0. So I factored out an m squared out of there and a 4 out of here. And so this is going to give me m plus 2. I'm factoring out the m plus 2 times m squared plus 4 equals 0. So I get m is equal to negative 2, or m squared is equal to negative 4. So m is plus or minus 2i. Alright, so here I have alpha is equal to 0 and beta is equal to 2. Alright, so this just goes back to what we learned earlier. So I've got y is equal to, that's going to be c1x to the negative 2. And then I have complex roots here, so that's going to be plus c2. Now remember for the complex, it's x to the alpha, whoops, it's x raised to the alpha times all of that sine and cosine stuff, but here alpha is 0, so that's just going to be a 1 out in front. Okay, so I don't need to put x to the alpha out here. Whoops, I done hit something. Alright, so that's going to give me c2 cosine 2 natural log x plus c3 sine of 2 natural log x. And this is your answer right here. Okay, this is some good stuff here. Alright, you're learning some good stuff. Alright, I think we only have, yeah, we got 2 more examples, so stick around, especially for the last example. Well, now we have see here we have a non-homogeneous equation. Okay, so let's go ahead and solve this. So remember, we've got to find our complementary solution yc, so we have to solve the homogeneous equation, and then we have to do what? We have to find the particular solution. Alright, so what I'm doing right now is I'm solving x squared y double prime minus 3xy prime plus 3y equals 0. That's the one I'm solving right now. So I've got y is equal to x to the m. Y prime is m times x to the m minus 1. Y double prime equals m times m minus 1 to x to the m minus 2. All right. And look, I've already plugged this in a bunch of times. Look, whenever you plug it in, you factor out the x to the m, you're going to end up with m squared minus 4m plus 3 equals 0. Okay, that's what you're going to get when we plug this back into the differential equation. We've done it, what, four times before this. You should know how to do this. All right, so that's going to give us m minus 1 times m minus 3 equals 0. So m equals 1 or m equals 3. All right. And so that's going to give me yc is equal to c1x plus c2x cubed. That's my complementary solution. All right. So now I need to solve this equation. I need to do my particular solution. So the first thing I'm going to need to do is divide everything by x squared. Okay, that's what we got to do first. So that's going to give me y double prime minus 3 over x y prime plus 3 over x squared. Y is equal to 2x squared e to the x. All right. All right, so now how are we going to go about solving this thing? Well, how about variation of parameters? All right. You just did that. You just did the variation of parameters. So we've got y1 is equal to x, y2 is equal to x cubed. Remember, this is your y1, this is your y2. All right. If you're not quite sure of this, search my channel. Differential equations, variation of parameters. Okay, and you'll see how to it's actually the video right before this one. Okay. All right. So what do we need? Well, we need what? W. Remember, W is y1, y2. And then it's y prime 1, which is 1, and then y prime 2, which is 3x squared. So that's 3x squared. Okay, and so this is going to be, what is that? 3x cubed minus x cubed is 2x cubed. Okay. So I'm going to box this in. You can box it in or put a star beside it because we're going to have to use that. It's just going to make it easier for me to go back and find. Okay. And then W1, that is equal to, so W1, remember, we take this, we're going to replace this with 0 f of x. Well, what is f of x? F of x is this. This is your f of x. It's 2x squared e to the x, and then we have x cubed 3x squared. All right, and so this is going to give us, that's 0 minus, and that's going to be what? 2x to the 5th e to the x, which is negative 2x to the 5th e to the x. And then we need W2. So that's going to be the x and the 1, and then we're going to, it's the x and the 1, and then we're going to replace this with 0 and f of x. So that's going to be 2x cubed e to the x minus 0, which is just 2x cubed e to the x. All right. And of course I'm going to use this and this. So if you remember, u prime 1 is equal to w1 over w, which is going to be negative 2x to the 5th e to the x over 2x cubed, which that is going to give me negative x squared e to the x. And then I have u prime 2. That's going to be w2 over w, which is 2x cubed e to the x over 2x cubed, which is equal to e to the x. All right, so that's nice. That's good for u prime 2. Well, what do we got to do? We got to let's get u1. That is going to be the integral. Now I'm going to bring the negative out here, x squared e to the x dx. So we got to integrate this to get u1, okay, because this is u prime. So what do we have here? Well, we've got what? Parts. So I'm going to let u equal x squared, dv equals e to the x dx. So du is 2x dx, and v is e to the x. So I've got x squared e to the x minus, now this times this, so I'm going to bring the 2 out, and that's x e to the x dx. And then look, don't forget you got that minus out front, so what I'm going to do is call that minus plus. I'm going to distribute that negative, okay? And then we've got to do parts again on this thing. So I get u is equal to x, dv is equal to e to the x dx, and so du is dx, v is e to the x. And so that's going to give me negative x squared e to the x plus 2 times, and that's going to be x e to the x minus the integral e to the x dx. And so that's going to give me negative x squared e to the x plus 2x e to the x, I'm going to distribute the 2, minus 2 times this integral. And when we integrate that, we just get e to the x. All right. All right, so it's not looking too bad. And then let's go ahead and find u2 is the integral of this thing. Let's see, because this is u prime. And so that's e to the x dx, which is equal to, well, just e to the x. All right. And what I'm going to do here is I'm going to write this up here. This is u2 equals integral e to the x dx, which is e to the x. I need a little more room here. All right. So now I get yp is equal to what? u1 times y1 plus u2 times y2. All right. And remember, y1 is x, y2 is x cubed. So let's just write that here. Let's write y1 is equal to x, y2 is equal to x cubed. So I get yp is equal to u1, which is negative x squared e to the x plus 2x e to the x minus 2 e to the x times x plus u2, which is e to the x times y2, which is times x cubed. And then when you distribute that, okay, we'll distribute that, clean it up a little bit. What are we going to get? We're going to get yp is equal to 2x squared e to the x minus 2x e to the x. That's yp. And recall that yc, I'm just going to write yc down here. Remember, yc, where is it? Is this. C1, there's YC, C1x, C2x cubed, C1x plus C2x cubed. So I get y is equal to YC plus YP, and that's going to be C1x plus C2x cubed plus 2x squared e to the x minus 2x e to the x. And there's your solution right there. All right, the last thing. All right, so we've seen how we've solved these things. Well, here we have a differential equation. Okay, it's similar to one we just did. Okay, now whenever you're working this, would you want to work it like the one we just did? Possibly. Okay, but let's work this one different. We're gonna reduce these the x squared and the x. We're gonna change them to constant coefficients. Okay, and this is how we do this. So reduction to constant coefficients. When the roots of the auxiliary equation for a y double prime that and a x squared y double prime bxy prime plus cy equals 0 are distinct and real, the respective general solutions are y equals c1 e to the m1x. Okay, remember you did that where these were constant coefficients. You had these as solutions. And then for this one, we just went over your solutions are going to be in this form, x to the m minus x to the m1 plus x to the m2. Okay, so with the identity e to the natural log x is equal to x is positive, the second solution above can be expressed in the same form as the first solution. Okay, so what we're doing is we're replacing the x with natural log x. You see that? Which is just equal to this. Okay, so let me just show you real quick here. This right here, how we go from here to here. So if you have, I'm gonna try to squeeze it in right here. If you have e to the m1, e to the getting ahead of myself, natural log x, we can write that as e to the m1 times what? Times e to the natural log x, right? Well, let me go back on that. That's not what I was wanting to do. That's not what I was wanting to show you. What we're doing here is to get the t here. I was thinking of something else. My mind wandered for a minute. Okay, that happens from time to time. All right, so what we're doing is this natural log x, we're replacing it with t. Okay, so where t is natural log x. This last result illustrates the fact that any Cauchy-Euler equation can always be rewritten as a linear differential equation with constant coefficients by means of the substitution x equals e to the t. Okay, so I mean that's from when if we're changing this. Okay, we're changing this right here to exponential form. All right, we want to solve the new differential equation in terms of t using previous methods and then resubstitute t equals natural log x into the general solution. Okay. All right, so let's look at this. So we're going to go and we're going to let x, change color back, x equal e to the t. E to the t. Okay, that's right here. Substitution x equal e to the t. Or we have t equals natural log x. Right? We can write it either way. All right, so what do we need? Well, we need the first derivative and we need the second derivative, don't we? All right, so we've got dy dx. See, I need the derivative of y with respect to x. So dy dx is dy dt times dt dx. All right, this is the same thing as this. Okay, I got the dy over dx, and those dt's would go out. That is equal to, all right, dy dt. I don't have y equals anything up here, so there's nothing I can really do. But dt dx, take the derivative of t with respect to x. That's what? That's 1 over x. That equals 1 over x, and then times the dy dt. Okay, so there's my first derivative. Now we need the second derivative of y with respect to x. Okay. All right. So what do we get here? So this is going to be d dx dy dt. I'm sorry, that's not dt. What am I writing dt for? Dx. So I'm writing this as d dx dy dx. Okay. And so this is going to be what? This is going to be d dx dy dt dt dx. All right, that's this. See, we wrote that up here also. That dy dx is this. All right. All right, so what do we do now? Now we've got product rule for this. All right, so what do we get there? Well, we get d dx, all right, dy dx dt dx plus dy dt d dx dt dx. And that's doing this. So I've got the derivative of dy dt times this plus dy dt times d dx of this. Okay, that's just the product rule. And so this is going to equal to, now let's, oh wait a minute, did I write something down wrong? I think I did. This should be a dt right here. There we go. Now dy dt, I'll put an x there. All right, so what we're going to do here is I'm gonna rewrite this just a little bit. I'm gonna write this as d dt dy dx dt dx. I put the dt under here and the dx under there, plus dy dt. So dy dt and what is that? Dt dx, that's going to be times 1 over x, right? Dt dx, if I take the derivative of t with respect to x, I get 1 over x there, right? Oh, d dx of 1 over x. Gets confusing with all these d's and x's and t's in there. All right, so let's see what we've got now. So we've got d dt, and then this is going to be 1 over x dy dt, right? See, I've got dy dx right here. Well, remember, dy dx is 1 over x dy dt. And that's going to be times dt dx. Well, we know dt dx, the derivative of this is just 1 over x. So that's going to be times 1 over x plus, and that's going to be what? Dy dt, and then the derivative of 1 over x is negative 1 over x squared. See, this is negative 1 over x squared. And so now, well, let's see, what is this gonna give me? This is gonna give me, 1 over x squared d2y dt2 minus 1 over x squared dy dt. All right, so we're getting everything in terms of t, so that's what we need. We need the derivative of y with respect to t instead of the derivative of y with respect to x. And for this, I can factor out, let's see, do I want to factor? Yeah, let's factor out a 1 over x squared, and that's going to give me d2y dt2 minus dy dt. All right, so now I have, notice here, we have y prime, okay, y prime, where is it? Y prime, this is y prime, is 1 over x dy dt, is 1 over x dy dt. And then y double prime is equal to 1 over x squared d2y dt2 minus dy dt. All right, and why is that so important? Well, because if you remember, we have x squared y double prime minus xy prime plus y equals natural log of x, right? And that's what we have. So what we're gonna have to do here is what? We're going to have to plug that into our differential equation. See, this is our differential equation here. We gotta know what y double prime and y prime are. And watch this. This is the neat part about this. So let's just plug everything in. So I get x squared times y double prime, which is 1 over x squared, second derivative of y with respect to t, minus the first derivative of y with respect to t, minus x times y prime. Well, y prime is 1 over x dy dx plus y. Okay, see, I mean, we want it in terms of y, right? That's y. It's y. See, it's y double prime, and y. All right, so let's see, what does that give us? Well, look at this. Isn't that nice how that and that cancel out? And I'm left with d2y dt2 minus dy dt minus dy. Oh, I put an x right there. That should be a dt. dt plus y equals, equals natural log. Well, I need to, natural log x is t. All right, I'm replacing natural log x with t. Where's it? See, right here, natural log x is t. And that equals t. And so I get d2y dt2 minus 2 dy dt plus y equals t. All right. And look what I did. It's exactly what it says it is, right? Right, what are we doing? Reduction to constant coefficients. So what we did is we rewrote the differential equations so it has constant coefficients. So you might be thinking to yourself, okay, so what's the big deal? Well, now we can go and solve it like we did those other methods. So now we have what we've got: m squared minus 2m plus 1 equals 0, right? We're going to solve the homogeneous one first. We got d2y dt2 minus 2 dy dt plus y equals 0. We got to solve the homogeneous equation first. So we got our auxiliary or characteristic equation. So that's going to be m minus 1 squared equals 0. M is equal to 1. So I got yc is c1 e to the x plus c2x e to the x. Oh, I'm sorry. Just a habit. It's just a habit. Oh, and that x should be a t. Okay, remember you're in terms of t. Don't do what I did. If you do, make sure you catch it. And so now we've got yp. Well, we've got a linear, right? So we can assume that it's going to be a plus bt. And so I've got y prime p is equal to b, y double prime p is equal to 0. And so what are we going to do? Well, we're going to take these and plug them into our differential equation right here. So that's going to be 0 minus 2b plus a plus bt equals t. All right, plug y double prime into here, y prime, which is just b, into here, and y, which is this, into there. And so I've got negative 2b plus a plus bt equals t. So this tells me negative 2b plus a is equal to 0 and b is equal to 1. See, this is your constant. I have no constant. And then this is the coefficient of t. So I've got b is equal to 1. So negative 2 times 1 plus a is equal to 0. And so that gives me a is equal to 2. And so now I get yp is equal to 2 plus t. So you plug the 2 in for a and the 1 in for b. All right, so now I have y is equal to yc plus yp, and that is equal to c1 e to the t plus c2 t e to the t plus, I said t and wrote x, t plus 2 plus t. Remember, we got our yc up here. Okay. All right. Well, that's great and everything. Everything's in terms of t, right? Everything's in terms of t. But let's go back up here and see what we have. What did we do here? I said x is e to the t and t is natural log of x. So I'm just going to write that down here so we can see it. We know that x is equal to e to the t and t is equal to natural log x. So we got to get this thing back in terms of t. All right, so that's going to give me y is equal to c1, and e to the t I'm going to replace with x, plus c2. Okay, e to the t is x, t is natural log x, and then plus 2, that's just a 2, plus t, and t is natural log x, and there is your solution. So that's a pretty good problem there. It's a lot going on. Okay, you know, if you took notes, you might want to, you know, go back and look at this, what we did here to get y double prime. See if you can follow it. It's not that bad. Okay. All right, well, that is this video. I hope you enjoyed it. I hope it helped. Check out my other videos. Give me a like, share, subscribe, comment, and I will see y'all in the next one. Later.